Hello again everyone, welcome back to ptet.chemistry channel. My name is Dr. Ant. In this tutorial video, we'll continue this combined science 5129. This is basically 3 sciences combined to one subject. It's equivalent to any 14 to 16 years old IGCSE, GCSE or O Level combined science curriculum. In this second bit, we are going to be looking at fuels. So fuels as components of crude oil, which we need to separate out using this technique called fractional distillation. It looks very long with all these lesson objective or learning objective, but it's very much a factual thing. And this part of the curriculum is exactly the same as those doing the pure sciences, triple sciences, or pure chemistry curriculum. And as such, I'm going to be using that part of the lecture tutorials to be appended into this particular lecture tutorial. So I'll be talking about fuels. These mainly comprises of fossil fuels that we derive from natural resources. So there's a bunch of syllabus objective here. So basically we're supposed to name the fossil fuels. So all of these come from fossil fuels. Number 1, natural coal. We have natural gas, and we have petroleum products. Petroleum products being very common in motor vehicles. Natural gas being very common to heat up our homes, especially if you live in countries that have winter, then they use natural gas for heating. But we also use natural gas for cooking purposes in a lot of countries. So we're going to be able to name methane. So methane is CH4. The natural gas we are talking about is the main constituent. So CH4 is basically your methane. They want the name. The name is methane. The chemical formula is CH4. We talked about hydrocarbon previously already when we talk about alkane and alkenes. Hydrocarbons, they are basically compounds that contain hydrogen and carbon atoms only. If you contain oxygen or nitrogen or any other element apart from hydrogen and carbon, you cannot call it hydrocarbon. And we're supposed to be able to state that petroleum is a mixture of hydrocarbons. So basically petroleum contains hydrogen and carbon containing compounds, but it's not pure, it's a mixture. And we're going to be able to separate them into useful fractions. We talked about fractional distillation back in year 9 when we covered experimental techniques. Fractional distillation works because of different boiling points. And we talk about simple covalent molecules. So these are all simple covalent molecules that you could boil them. Because simple covalent molecules, you just need very little energy to break the weak intermolecular forces of attraction between the molecules. So low boiling point, but regardless, they have different boiling points, which you can then separate them by fractional distillation. Within the fractional distillation thing, the setup from the bottom to the top. So the bottom will be the heavy one, and then the top one will be the lightest fractions, whereas the heavy fractions will be obtained at the bottom of the fractionating column. So difference between fractional distillation and a simple distillation is that in a fractional distillation, you collect many different fractions and you will have a long and a tall fractionating column. We'll talk about all of these as we progress through this particular lecture tutorial. There is a bunch of fractions that unfortunately these are just naming the fractions as well as the uses. We are supposed to look out for a couple of things. Butamines are the heavy fraction. It is the heaviest fraction. It will be found at the bottom of the fractionating column. We use it to make roads. And then the gases are going to be the lightest. So they will, float all the way to the top of the fractionating column. This is about the refinery gas fraction for gas. We use it for heating homes as well as for cooking at homes. Remember that the main constituent, of natural gas is what you call methane, and that was as stated in the syllabus previously. So I'm just going to move up a little bit. Name methane as the main constituent of natural gas. This refinery gas fraction for gas used in heating and cooking mainly consists of methane. Our car petroleum is somewhere just below refinery gas fractions, and it gets heavier and heavier and heavier as these are the other fractions and these are the associated uses. Just to quickly recap back what I've gone through in the syllabus objective, we have a couple of fossil fuels. We need to name them, so make sure that you can name Oops, make sure you can name these fossil fuels. Number 1, coal. Number 2, natural gas. Number 3, petroleum products. The main constituent of natural gas is methane. Methane is CH4. This is the display formula with carbon bonded to 4 single covalent bonds. Of course, then you can draw the dot and cross diagram where each single line there is representing 2 electrons being shared. So that is the dot and cross for methane there. And what you could do is you could do as what I've done there without the shell, or you could draw the one with the shells. As long as you have fully filled out the shell for both the carbon and the hydrogen, they will be alright for the dot and cross there. This is a common definition. Hydrocarbons, they are compounds because they contain the carbon and the hydrogen chemically bonded together in a fixed ratio. That's the definition of compounds from year 9. From year 9 definition. But hydrocarbon is organic chemistry, year 10, year 11 definition. Compounds containing carbon and hydrogen atoms only. We also talk about saturated and unsaturated hydrocarbon. Saturated hydrocarbons, typically alkanes. We talk about single carbon-carbon covalent bond. And then when we talk about unsaturated, we talk about carbon-carbon multiple bonds. Could be carbon-carbon double bond. Could also even include carbon-carbon triple bond. This is less common in your O Level or IGCSE chemistry. But unsaturated basically means multiple covalent bonds between the carbon atoms. Now, petroleum is a mixture of hydrocarbons. These hydrocarbons have different boiling points, and that is why you can separate them into the fractions you want. Based on their different boiling points, you can do fractional distillation of crude oil. This is a fixed full essay that you are supposed to be able to describe at this particular 14 to 16 years old level chemistry. All these fractions that you are separating, they have low boiling point. So low boiling point because they have simple covalent structure, number 1. And then number 2, what is involved in breaking this particular, what is being broken essentially when you want to melt or boil this simple covalent structure. You only need to break the weak intermolecular force of attraction between the molecules, such as if I have CH4 like this. So we have strong covalent bonds which we never break if we have simple covalent molecules. If we want to boil or melt them, we never break the strong covalent bond. So what am I talking about? I'm talking about if I have another methane molecule with strong covalent bond between the carbon and hydrogen, but in between the molecules, the word inter there refers to in between the molecules. These are your weak intermolecular forces of attraction from your year 9 structure and bonding. So that means when we go from liquid to gas, because distillation involve boiling. So when you go from liquid to gas, you are separating the molecules, becoming further apart, but you are not breaking the covalent bonds. You still have CH4 as a liquid, going to CH4 as a gas. You didn't break the covalent bond. You break the weak intermolecular forces of attraction. Therefore, you have low melting point, low boiling point, year 9 structure and bonding there. Above point must be included whenever you talk about explaining the melting and boiling point. So how does this fractionating column or fractional distillation works? Crude oil will enter the fractionating column. So it is a tall tower. You have the crude oil coming in. The crude oil has to be heated because you need energy in order to break the weak intermolecular force of attraction. So we are heating up the crude oil. The boiling bit is the first part of distillation. We heat it to form vapor or gas. That's the first point there. Now, these different fractions will get separated by this technique called fractional distillation because we are collecting many different fractions. This bit being the top of the tower at the very top. This thing being the bottom of the tower at the very bottom. So we have fractional distillation. It separates fractions of the crude oil, different fractions of the crude oil based on their different boiling point. Of course, then the top bit, the top fraction there involve the lightest molecule, the lightest fraction, involve the one with the lowest boiling point, because if you boil first, you're going to go to the very top of the tower. Since you are the lightest, you have the weakest intermolecular forces. Therefore, you require the least amount of energy in order to separate the molecules apart, and therefore your lowest boiling point. You're also the lightest, typically the shortest carbon chain, the small size hydrocarbons, the most volatile meaning the lowest boiling point, easiest to boil. This all comes down to languages, so make sure you know how to play around with the languages a little bit. And what we collect at the top of the tower: easiest to boil, most volatile, smaller size, shortest chain hydrocarbon, it boil first. And we need to talk about at the bottom, at the opposite end, further down in the column. As we go down the column, the fractions we're collecting would get bigger in size. So we can say bigger in size. So bigger size, longer chain meaning more carbon in the chain. Therefore, we can talk about higher boiling point due to stronger intermolecular forces. Therefore, higher boiling point. We can talk about heavier fraction as well. So all these are basically the fractions that we're supposed to get. There is also one more thing. This is called more viscous. So viscous is like the stickiness. So stickiness. So why is it getting more viscous? Because you have stronger intermolecular forces. If the force of attraction between the molecule gets stronger and stronger, they will prefer to stick together. And as mentioned before, as the boiling point increases based on these two factors, therefore you do get stronger intermolecular forces, you get heavier fractions, we also get more viscous fraction. So as you can imagine, petroleum in car is already a bit viscous, so oil doesn't flow as easily as water. So we can say oil is more viscous than water. But then when you get to diesel, which is heavier fraction, it will be more viscous than your normal petroleum. When you get to bitumen, it's more like a solid unless you melt it at a very high temperature. But when you pave the road surface, you don't see your road being liquid. You see the road surface being solid because you heated it up so that it melts to give you the bitumen, and then you can pave the road surface. When it cools down, it will solidify, and that is the road that we use on day-to-day basis. The top of the fractions, we get refinery gases. These are the bottle gas used for cooking as well as heating homes in countries that have winter. We have gasoline, which are basically the fuel for cars, petroleum products for cars. Kerosene is a heavier fraction. We use it in aircraft fuel for aeroplanes. Diesel, very common in heavier vehicles as well as machineries. So these are used in cars. Well, some cars are diesel cars because they save a lot more petrol in the long run. Lorries, trucks, buses, trailers, they all use diesel primarily. Then we have fuel oil. So these are like lubricating oils, and they are used in power stations, fuel for ships and stuff. Lastly, we have bitumen, which are used for making roads as well as, making roads. That's the most common thing. There are one or two more fractions. They are stated in the syllabus. They were not in that diagram. So we need to always check back the syllabus. The syllabus have a few extra ones, including naphtha, which is very important. So just to recap what we have done, to describe the full assay for fractional distillation of crude oil, the crude oil has to be heated, and then when it enters the column, it will already vaporize as it has been heated, so it already boiled. But the higher up you go in the fractionating column, these are the lighter fraction. So I can comment on this again. These are lighter fraction. And these are shorter fraction, shorter chain. We can talk about smaller molecules. These are lower boiling point. These are less viscous. And we can say weaker intermolecular forces. And then as we go down the series, we will have longer carbon chain length. And as a result, we got higher boiling point due to stronger intermolecular forces. Therefore, they have a higher boiling point, meaning to say lower volatility. They become more viscous as the intermolecular force attraction between the molecule is stronger, but they also have higher density. So they get heavier and heavier as you go down this column. Refinery gas, as mentioned, you use it for heating and also cooking. Gasoline or petrol, we use it in cars to run our cars. Naphtha was previously the one which was not in the previous diagram, but this is in the syllabus. Naphtha is very important. We use it as a chemical feedstock. So it's like middle range carbon chain, not really useful for cars, but you do need naphtha as a chemical feedstock for making other useful organic products. One of the things including plastics. So our plastic products come from this chemical feedstock as a result of naphtha being separated in this fractional distillation. Kerosene, which is used as a jet fuel. So this jet fuel, or you can say in aircraft. So this uses kerosene or paraffin. Diesel oil is used in diesel engines. So we have lorries, we have trucks, we have trailers. So a lot of those heavy machinery, they uses mainly diesels. What else can I mention here? Fuel oil. Fuel oil is used in ships and home heating system. Lubricating oil are mainly for lubricants, waxes, and also polishes. And bitumen, last but not least, is used for making roads. So there are a couple of things that were not included in the previous diagram. Naphtha was one of them. It sits in between petrol and kerosene for petroleum, for aircraft use. And we also have fuel oil and lubricating oil in between diesel and bitumen. So just something for you to keep note of as per the syllabus. I think I'll leave it there for these lecture tutorials, and I'll continue more on alkane and alkenes in the next series of these organic chemistry tutorials. So thank you for watching. Don't forget to click the button on the bottom right to subscribe to my channel. Do follow me at ptet.chemistry. There's at ptet.chemistry on Instagram, Facebook, Twitter, and Telegram to get connected. I'll see you in the next lecture tutorial.